This is Emily Lee, and I am here to talk about the chemistry of water today for the first exam video. We are going to look at an H2O molecule, and we're going to talk about the bonds that end up between them and what that all means. First thing we're going to look at is a molecule of water. As you can see right here, there's a bunch of strange little lines, a bunch of weird symbols, and some weird dotted lines. And we're going to explain what this all means. What are these lines between the oxygen and hydrogen molecules? Why do some of these molecules have different little squiggly things? And when water bonds together, what kind of bond that is? So the thing that is most important to talk about is what is electronegativity. Electronegativity is essentially how much an element wants to essentially grab an electron from something, how easily it is able to take an electron. It is calculated from a scale of 0 to 4, and certain elements have less electronegativity, like hydrogen, compared to oxygen, which really wants to grab an electron. Every element with a full shell of valence electrons tends to be the most stable, and they want to approach that sort of state. Between different elements and elements, there are three kinds of bonds. There is nonpolar covalent bonds, which when you calculate the electronegativity, it is less or equal to 0.4. And between these elements, it means that electrons are fairly shared evenly, so there's not really much of a charge. You have polar covalent bonds, which is between 0.4 and 1.7 electronegativity difference. And it means that one element is taking a little bit more electrons compared to another, so it's called a partial charge in between the different elements. And then you have ionic covalent bonds, in which one element gives an electron to another that is greater or equal to 1.7. And between the different elements, one is wholly charged positively and the other one is wholly charged negatively. So to calculate our electronegativity, it's a pretty simple process. You go to the electronegativity chart of the different elements, you take the big one, you subtract it by the smaller one, and you get a number. So for instance, oxygen is 3.5 minus hydrogen is 2.1. You get 1.4. And you can see that means it is a polar covalent bond. So we know that the bonds between oxygen and hydrogen are covalent bonds, polar covalent bonds, which means that between the different different elements, there are partial charges. And we represent it by the delta symbol. So oxygen being the one with the greater electronegativity, it means it is partially negative. And hydrogen, therefore, is partially positive because the oxygen is taking the hydrogen electrons. Finally, what happens between the different water molecules? So we have here three water molecules, and there's these bonds between the hydrogens and oxygens of different water molecules. Because the hydrogens are partially charged positively and the oxygens are partially charged negatively, we get things called hydrogen bonds, in which, because they are slightly attracted to each other, it's not like polar covalent bonds, but because they're different between different molecules, these hydrogen bonds form. And that's about it. That's all about the chemistry of water.